Hello viewers, welcome to my channel. Today we shall be looking at the topic change of subject formula. This is a crucial topic in science, of which in physics, chemistry, and some other science subjects that require calculation, one may be required to navigate between different variables in given equations. Here we have a series of questions to address from number 1 to number 5. By the time we are done solving these questions, you must have been familiar with the concept of change of subject formula and should be able to solve any question that is being presented to you in any examination. Now let's begin with the first question we have on the board. Please don't forget to click on the subscribe button as we continue to make mathematics easy and simple for you. Now for the first question, the idea here is to make W the subject of the formula. And what it entails is to make this W to stand on its own. In an equation, there is always an equal sign. So in that equal sign, there is the right-hand side of the equation and the left-hand side of the equation. So all we need to do is to make sure that W stands on its own. Is it that it stands on its own at the right or it stands on its own at the left? That is exactly what we mean by making it subject of the formula. The subject means that you have to pronounce it. It has to be the subject for which others depends. Just like when you are asked to identify the area of a triangle, you say A is equal to half base times time. Half base times height, rather. So this A becomes the subject for which this was relied upon. So we are making W the subject of the entire variables that we have in this equation. So now to do that, we have to ensure that W stands on its own at one side of the equation. And for us to do that, we have to let every other variable leave this side so that W will be able to stand on its own. How do we do that? We have to start by saying P, then plus B will have to move over here. And it's plus B. When it moves across the equal sign, that becomes negative B equal to, we have it as A, W. Remember, our projection is to make W subject of the formula. All right, so what next do we do to ensure that this A leaves W alone so that W will stand here on its own? All right, so for us to do that, we have to divide both sides by the coefficient of the W. In this case, the coefficient of W is A. So by so doing, we divide both sides by the coefficient of W, which is A. Let's rewrite them again. P minus B equal to A W. Dividing both sides by the coefficients of W, which is A. I divide this side by A. I divide this side by A. A will now cancel A here. We are left with only W. So we can say that this W is now the subject for which all of these variables depends upon. So the answer becomes W is equal to the entire thing we have here. P minus B all over A. This becomes the answer to the question. That is exactly what we mean by making a certain variable subject of the formula. To let that particular alphabet you are making subject of the formula to stand on its own. That is just the idea. Let's take number 2. Then for the number 2 question, here we have a v squared equal to u squared plus 2as. We are to make u subject of the formula. That is to say, we are to make u to stand on its own. This question is quite easy. All we need to do is to let all this particular term here, to move over to the left hand side so that u can now stand alone. By so doing, we have it as v squared, then plus 2as, moving over to this side become minus 2as equal to u squared. So we can write it as u squared is equal to v squared minus 2as. All right, so what do we do next? Because we are required to make u subject of the formula and not u squared. So we have to make sure that this square leaves u, so that we can only have u there. Recall that whenever you are solving a question, for example, you have x raised to power 2 is equal to 16, and you are asked to solve for x. What you do in order to eliminate this is to apply square root to both sides. When you apply square root to both sides, of which power 1 over 2 is something as square root, these two will cancel out 2, and you have it as 1 over 2 here, which also represents the square root. So whenever you have x squared equal to 16, then what you have to do is to apply square root to both sides. If you have square, apply square root. So it will now be x is equal to square root of what? 16. All right, so of which the final answer becomes what? 4. Then in this particular instance that we have, all we are required to do is to make sure that that square that is hanging on u leaves it alone so that it can stand on its own. So what do we do here? We have to apply square root on both sides so that this square will go. So by so doing, we now have it as u is equal to square root of v squared minus 2as. This becomes the solution to this particular one, because our question says that we should make u subject to the formula. That is to say, we have to make u to stand on its own. That is the idea. Recall, if you have it as u cubed equal to v squared minus 2as, how do you write the answer? That's applying cube root. If you have cube, apply cube root. If you have square, apply square root. So for this one, all we are supposed to have here will now be v squared minus 2as. That is to say, if what we're having here is cube. All right, so let's now move to number 3. I hope this is quite understandable. All right, so let's move to number 3. Maybe you can give that one a try. You can give number 3 a try. For the example 3, what we have here is d equal to square root of 3h all over 2. And we have to make h subject to the formula. That is to say, we have to make h to stand alone. But there's something I want us to clear here. Recall, I once said when you have x squared equal to 16, if you have square, what do? You apply square root. That becomes the square root of 16. What if you have it this way? Square root of x equal to 4, for example, and you're asked to find the value of x. If you have square root, you apply square. So it's a converse of the other. So when you have square, apply square root to both sides. If you have square root, then apply square to both sides. All that is quite clear. All right, so as we have this now, that becomes x equal to 4 squared. So when you have square root in the variable you are looking for, then you have, for it to come out of that particular square root, to cancel it out, then you have to apply square to every other variable that exists there. All right, so that's exactly what we're going to be seeing in this particular example. And look at what we're going to do there. So we are looking for the value of that for h. We're making h solid a formula. And what we are supposed to do here is to do what? First of all, to eliminate this square root so that everything will be open. And how do we do that? Since what we are looking for is inside the square root, we have to apply square to both sides because we have square root here. So as you have square root, you apply square to both sides so that it can clear. So applying square to both sides, this square here will cancel out the square root that we have. Then we apply the square at the other side. So whatever you do at this side, do the same thing at the other side. So we now have it as d squared is equal to 3h all over 2. So if you have square root, you apply square to other variables outside of that particular square root. All right, so what do we do next? We have to make h solid formula. We collect like term by, dividing across the board. So we have to cross multiply. We have to cross multiply. You multiply. So when we cross multiply, we now have it as 1 times 3h will give us 3h. Then d raised to power 2 times 2 will give us what? 2d raised to power 2. So how do we now finalize this to make h to stand alone? Because the major aim here is to ensure that h stands alone. And that's why we call it what? Change of subject what? Formula. All right, so to make h subject of the formula here, What do we do to make this 3 leave h alone? Can you suggest that? I know somebody must have gotten the answer. We are to divide both sides by the coefficient of h. Of course, the coefficient of h in this particular instance is what? 3. So we divide 3 by both sides. Then here, 3 is cancelled out. Therefore, our h is now equal to 2d squared all over 3. That becomes the answer to this particular one. I hope this is quite clear. All right, so let's now move to number 4. You can still give it a try because it has to do with square root as well. Let's see how you do that. Now for the number 4. Now for the number 4 question, here we have r is equal to square root of ax minus b all over q plus bx. And we are to make x subject of the formula. I know this is kind of question that confuses most of the students, of which I'm going to make it very clear for you to understand right now. Okay, so recall what we did when we were having square roots. So, and what we are looking for is within the square root. So what do we do to eliminate the square root? We have to apply square to every other thing outside of the square root. So to do that, to cancel this square, we have to apply, a square root, we have to apply square here. That becomes r squared is equal to ax minus b all over q plus bx. This is what we have to do. So now we have eliminated the square root, okay, by applying square to both sides. All right, so the next thing we have to do is to cross multiply. We cross multiply. So that will now be 1 times ax minus b will give us ax minus b equal to r squared times this means the same thing as r squared bracket q plus bx. So that's the meaning of the same thing as r squared times q plus bx. So we have to put both of them in a bracket because this r squared multiplies every bit of this. All right, so we move ahead. That is to open this bracket that we have here. That becomes ax minus b is equal to r squared times q will give us what? Qr squared or r squared q. Qr squared. Then r squared multiplied by bx will give us what? Plus bx r squared. I hope this is getting interesting. All right, so the next step we are going to take now will be, because we can't be having x on different sides, or to say x is equal to something that involves x. So since we have x scattered at both sides of the equation, what we are going to be doing is to collect like terms, to bring anything that has to do with x together. I will have to make sure that we keep everything as positive as possible. Very, very important. So you can see we have a ax here. X is involved in this one, and x is also involved in this one. So we have to bring them together. So we have this one here already, which is ax, then plus bxr squared. The reason why we are bringing it together is that we want to get x in common, to bring them together where they should belong. All right, so we are collecting like term. Anything that has to do with x, since we are making x out of the formula, we have to bring them at same position. So plus bx r squared coming to this side becomes minus, because it's positive here. Coming to this side become minus bx, then r squared equal to, we already have this one here, which is q r squared. Then minus p has to leave, so that all those that has to do with x will be at one side. So minus p moving over to this side become what? Plus p. I hope it's getting very interesting. All right, so let's now do something here. What we are going to do is that we are going to collect like terms. Okay, like term, we have done that already. Then we have to factorize. Factorization here means that we have to look for something both of these expressions have in common. So they have x in common. We factorize it by getting the items they have in common. And the item they have in common here is x. So x divide ax will give us a. X divide b minus b x r squared will give us b r squared. So that's what we're going to have there. Then equal to q r squared plus p. I explain again. What we did here was to collect like terms to get everything that has to do with x to a common side. All right, so that is to say we have ax here. Then this one has to do with x, that is plus bx squared. We have to bring it over here to become minus bx r squared. Remember that when an expression moves across the equal sign, the sign changes. All right, so that will now be equal to, we already have this one here. The minus p has to leave to the other side. That is minus p coming over here become plus p. Okay, so now what we have to do here is to factorize. Factorization here, we have to get something they have in common and leave others in bracket. All right, so that's exactly what we have been able to do here. So now we can see that we have 1x standing on its own. So the last thing we're going to do is to make sure that this x stands alone at one side. And what do we do about that? We have to divide both sides by the coefficient of x. And the coefficient of x here is the entire bracket that we have here. So that will now give us x is now equal to q r squared plus b over a minus b r squared. So this becomes the solution to this question. There is nothing you can do. You can't cancel r here. The reason is because you have a plus sign here. So because it is not a product, so you can't cancel r squared cancel r squared. No, you don't do that. All right, so this becomes the final solution to the question. I hope this is quite clear. All right, so please don't forget to click on the subscribe button as we continue to make mathematics easy and simple for you, and also for you to be able to receive notification for other interesting topics as we're posting them online. Please click on the subscribe button to support the channel. All right, so let's take number 5 question. Maybe you can give it a try. Now for the number 5 question, here we have I is equal to E all over square root of r squared plus w squared l squared. So how do we do this? And we are required to make r the subject. We have to make r subject of the formula. All right, so what we are going to do, what we are looking for is inside the square root. Remember, whenever what we are looking for is inside the square root given in that particular question, you have to make every other variable outside of the bracket squared. Because what we do to eliminate the square root is to apply square. And when we apply square, the square will cancel the square root that we have here. Then every other thing we have squares. All right, so to cancel this, we have to apply square to both sides. And by so doing, we have this as I squared equal to E squared all over R squared plus W squared L squared. That is how to get it done, not to remove, to do away with the square root that we have here. So remember, when you have square root, you apply square. Okay, so if you have square, you apply square root. Now, let's make R the subject of the formula. So the next thing we are going to do is to cross multiply. Then when we cross multiply, let's start with this. That will be I squared multiply R squared plus W squared L squared. That will give us I squared bracket. Because this multiply everything here, we put them in bracket. That's R squared plus W squared L squared is equal to 1 times E squared will give us what? E squared. All right, so the next thing we have to do is to open the brackets. For what we are looking for is R. We are making R sort of formula, so we have to bring it out of the bracket. So that will now be I squared times R squared will give us I squared R squared plus I squared multiply W squared L squared will give us I squared W squared L squared equal to E squared. Wow, and we are looking for R. So we have to take this to the right hand side. Our intention is to let R to stand alone. And by so doing, we have to get rid of this to the other side of the equation. That will not be I squared R squared is equal to, we have E here, E squared, then plus I squared W squared L squared. They are product. Then it is positive here. Moving over to the other side of the equation to meet E squared. Now we'll now assume it to be minus I squared W squared L squared. Now what is left for us to do is to now let I squared leave the R squared alone so that we'll be able to solve for R only. And for us to do that, we have to divide both sides by the coefficients of R squared. The coefficients of R squared here is what? I squared. So that becomes R squared is equal to E squared minus I squared W squared L squared all over I squared. That is what we are to do in this particular one. So that is not all. The remaining step for us to follow here is that we are asked to make our sort of the formula and not square. Can you recall what we said about when you have square? What do you apply? If you have square, you apply square root. That is exactly what we do. All right, so in order to eliminate this square here, we have to apply square root. Therefore, r will now be equal to square root of e squared minus I squared W squared L squared all over I squared. That becomes the answer to this question. There are many ways you can write the answer. The answer can also be presented in this form. R is equal to square root of E squared over I squared minus I squared W squared L squared all over I squared. The answer can be written like this also, of which if you solve the fraction to compress it, you will still have this back. So this is exactly how to do change of subject formula. I hope this is quite understandable. Please don't forget to click on the subscribe button to support the channel as we continue to post more videos that will make you to understand mathematics even more. Thank you so very much for listening and have a great day. Bye.